All right, so let's take a look at these. If you just joined us here, the 4 questions are warm-ups just to help us practice with factoring. And this has been one of the skills that historically students struggle with on this chapter, this test. So we wanted to give you a little extra practice. I have the sum and difference of cubes formulas up here. So when you need it, I'll pull that up shortly here. But let's look at number 1 quick. And I know we talked a little bit about these yesterday. We just didn't go all the way through them. So there's 4 terms. So we're going to see if grouping works. Not a guarantee, but this one I believe does work. So if I take a look at the first one, I can pull an x squared from the red terms. And what's left over is an x minus 3. And then from the blue set of parentheses, I can take out a negative 4. And my goal then is to make sure what's left over in the parentheses looks exactly like what was left over in the red parentheses. Because that's how we know that grouping works. Sometimes that's not the case and we can't actually factor this then. But what's left over is now both pieces, both the left and the right side, have a factor of x minus 3 in common. And what's left over is the x squared minus 4. And we should always ask ourselves, can we factor further? And in this case, the red and the blue terms can actually be factored into an x minus 2 and an x plus 2. And the reason why we know that, 2 things, is it's the subtraction sign and the 4 is a perfect square. So then my final answer in complete factored form is right there. Now, just a quick side note, what if I told you to solve? Would you change anything that you've done so far? No, you just add on to the work, right? If I said solve, then you'd set the whole thing equal to 0 and set each parenthesis equal to 0, and you'd get your 3 answers. So we're not going to do that for this one, but so yesterday we did talk about number 2. I'm going to rewrite this over here quick. So the way I like to think about number 2 is we can change the appearance of 8 and 27. Right? 8 can be thought of as 2 to the 3rd power, and 27 can be thought of as 3 to the 3rd power. So those are themselves perfect cubes. And then we've got x to the 3rd. And the way we want to think about this one then is if I have 2 and x both to the 3rd power, we can rewrite those. So it's 2x to the 3rd power plus 3 to the 3rd power. So all of that is just rewriting it so we can get used to this sum or difference of cubes. And it's addition, we have a cube plus a cube. So we'll use the pattern for the sum of cubes, which, if you really want to, you could call A is the 2x. So anywhere you see an A, you know it's going to be a 2x. The B is 3, and then plug it in and just simplify. So once you get it in this form, it's a pretty friendly pattern, assuming you have this either memorized or written down. So what would we get? We would have A plus B, so 2x plus 3 times A squared. Now some students have done this, which is completely fine. And then they're going to show work after that. So all I'm doing is taking the A and squaring it. And then I'm going to subtract A times B. So what is A? A is 2x times B, which is 3, plus whatever B is squared. So it's kind of like filling in all the spots, and now we can simplify once all that's in, or you could do that in your head. So just to finalize this, usually the error occurs right here. If somebody's going to make a mistake, you have to think of 2x being squared. That tells you to take 2x times 2x. So 2x times 2x is 4x squared. And then 2x times 3 is minus 6x plus 9. And the best part about this pattern is once you use it, that's as far as you can go. It doesn't break down any further. So, there it is. All right, number 3 is the one where we have to pull out the common term first. So, every single term has an x squared in common. And when I pull out that common monomial term, what's left over is a new expression. And what we want to do is we want to see if we can factor that expression using whatever methods we need. In this case, you might be able to do this in your head, which maybe you want to. Or you could use the box with the circle in it. So when I try to factor 4x, or x to the 4th plus 5x squared minus 6, we would multiply the two corners. And then I'm looking for factors of 6x to the 4th. So we get a positive 2x squared, positive 3x squared. And then we can factor out an x squared across the top, a 3 across the bottom, another x squared across the top, and a 2. And then just remember, that's not your final answer. Would I get 100% if I said that's my answer? What's missing? X squared. And that's another common mistake. A lot of students forget that we pulled out an x squared to make this problem easier to work with, but we can't forget about that as a factor. So make sure you put that in. All right, and then my favorite, the last one. This is the one that always stumps kids, because they're always looking for what method is it? Is it grouping? Is it a perfect cube? Is it the quadratics, where you're using the box and the circle? Well, in this case, there's only 2 terms. So all you need to do is say, what do they have in common? And one of the things you could do, if you really want to, is create a box. I love the way that negative hit you. The negative belongs to the 48. But we can factor like this. What do both items have in common? What's the largest term we can take away from each one? We for sure can do an x squared. Does 3 go into 48? How many times? So I take that 3x squared out, and then what's left over is an x squared minus 16. But again, that's not my answer. My answer is written in the factor form. And if I stop there, would I get full credit? You can always try to factor further. It's not always going to work, but in this case, what do we notice? We have a subtraction, and we have a perfect square. X minus 4, x plus 4. Gives us complete factors. Okay, hopefully this gave you a little bit of an idea of, okay, factoring is not easy. It takes practice, it takes skill, and there might be a couple methods you're really good at, and there might be a couple methods that you need to study a little bit more before the test on Friday. Okay, so what we're going to do is jump into the Kahoot right now. So if you guys want to either get out a cell phone or your computer, I will put the join code up. And again, I always like to just share that the goal is not to win. I don't really care if you answer it first or last. If you answer correctly, that's the key. And if you could get it, but time ran up, that's all right as well. This isn't a race. It's just that's the way Kahoot works. So here's the game pin. Go to www.kahoot.it or use your app, and I'll wait for everybody to join. All right, so we got about 20 people. Got a few more left to join. All right, so we're going to get started here. You guys can join kind of at any time. I believe the pin code is down here at the bottom. So simplify the expression. All right. Correct answer is option 11. I'm going to do these pretty quick just to give you guys some feedback. So remember, we don't like subtraction. We like to think of it as adding the opposite. And then you're going to combine your like terms. So we don't have a 3 to the 4th, but we do have the thirds. So I get negative 10 to the 3rd. The minus 7p doesn't have any terms to join with, and then plus 5 plus 6 plus 11. Okay, and I didn't even answer it, unless somebody joined in as my name, which, nicely done. All right, let's try number 2. Multiply. Oh, sorry, I just realized I was blocking the answer. Alright, so let's go look at this one. What I was trying to do, I was going to pull this over and then have it pre-set up. So I didn't have to waste time. But then I blocked an answer, and you probably got frustrated. You could do the arrows, personally. I think less mistakes are made with the box method. So multiply. And then once you have your like terms are in the diagonal, so 3, so end of the third plus 3n squared plus 1n plus. All right, next one. What is the constant term? All right, 27 is the right answer. Definitely one we want to look at. And I'll give you a quick little idea of how or why this could be as quick as possible. If you think of it, you're going to have x plus 3 times itself 3 times, but we're looking at just what is the constant term. So all I care about is this 3. And if you think of it, the 3 is going to be multiplied by itself 3 times. when you have something set up like this. So without multiplying all this together, 3 times 3 times 3, or a better way to think of it, is the constant term is just 3 to the third power, which is 24. So, kind of a quick one. If you took the longer approach to multiplying it all the way out, you'd still get the same answer. Ooh, Yasmin, you overtook Mr. Stroud. All right, next one. Divide. So that one might have taken a little bit longer. I think the max time we can have is 2 minutes on this, which is unfortunate. But if you guys would like to kind of finish that problem, we can check to see. The answer is 9. I will go over it here in just a second. All right. What method would you use to divide here? Synthetic? I would, because this is a linear factor. However, you could also use long division. Long division would work as well. The one thing that could trick people is, if you notice, you don't have an x squared term, so you have to have that place value, and that's usually where, if you make a mistake, the error occurs. So what we're going to do then is take the coefficients, plug them in. The other error, other than forgetting that 0, is remembering what goes on the outside of the synthetic division. It's what makes the linear expression equal to 0. So it's the 3 that would go here. And once you have that set up, remember the 2 has to give us something to start with. So the 2 drops down, and then we go back up by multiplying. So 2 times 3 is 6. And then to go back down, we add. 2. Multiply to go back up. 3 times 2 is 6. Add, go back down. Multiply to go back up. add, go back down, and multiply, go back up. Add, go back down. So that leaves me with my remainder. And then that's important to remember. We have the constant term, x, x squared, and x to the third. So, again, this isn't my answer, right? My answer has to be written out as a polynomial with the remainder divided by whatever the linear function originally was. All right, a couple people just joined. We're doing the Kahoot right now. You can join in kind of halfway through. At the bottom of the screen, there's the game pin. All right. Next question. Nice. Factor completely. All right. One of the key things, and it's kind of hard to see, but notice how everything has a 5x in common. So right away, that eliminates the green one. And I can't see the... And it eliminates the yellow one. So it kind of leaves us with a 50-50 shot then. But let's look at this one just a little bit closer. Weird. So everything has a 5x in common. It's almost 5 comes out and left with x squared plus x plus 6. And then you can probably do this in your head. What are factors? Wait, did I do that right? Yeah, that's the answer. That's it. Oh, yeah. Because I can't factor this any further because there aren't any factors of 6 that add up to 1. So that's as far as you can go. Back in the lead. All right, next one, factor completely. real quick way to do this one is to notice how there's a minus, and the 9 and the 64 are both perfect squares. So how did I get 9? 3y times 3y. How did I get negative 64? 8 and negative. So that's kind of a real quick way to do that. If not, you could, like, let's say that you didn't notice that pattern. How else could you have solved this? This is probably not recommended because the numbers are really large, but it's missing the 0y term. So if you ever come across something like this and you don't recognize the pattern, the long, kind of tedious way to do it would be to multiply 9 times 64, which is a really big number, and then look for the factors that add up to 0. I don't recommend it. I think it's better to say, here's a perfect square and here's a perfect square, and this is subtraction. So you can set it up as 3y times 3y and minus 8 and positive 8. All right. Close race. Number 7. Find the remainder when this function is divided by x minus 3. All right, so this one is another division one, which means you could do either synthetic or long division because we have a linear factor we're dividing by. There are no missing terms, 3, 2, 1 constant, so we don't have to worry about any of that. And then here we would have x equals 3 because that's what makes the linear factor 0. And then this question just says, what's the remainder? So I'm going to do this as quick as I can, which means I'll probably make a mistake. So let me know when I do. 672. Okay. And add, that's 65. And 180. That's 195. And then we get 198. Assuming I didn't make any mistakes, what's the remainder? 198. Yay. All right. You guys are getting close. All right. Number 8, write a polynomial with a y-intercept of 16 and zeros at -1, 2, and 4. You need a hint. This is like our warm-up from the other day. All right. Now, you could do a lot of work to get this answer, or you could do a little. If we look at the zeros, think of what made those factors. If I move the negative 1 over with the x, then that's going to be an x plus 1. So I have to have an x plus 1 in the equation, which automatically says it's either the red or the yellow. And then same thing with the 2 and the 4. So notice those factors are the same. So then I would just be checking the y-intercept, which is when x is equal to 0. So it's really just saying what's the constant term. If you multiply it all together, and if you multiply all the terms together, do they equal negative 16? So let me show you what I mean here. And this kind of got printed funny, but I had x minus 1, so I moved the 1 over. And then I had x equals 2, so I get x minus 2 as a factor. And then x equals 4, so I get x minus 4. And if we were to do this by hand, so notice I don't have my multiple choice options here. Remember there's that a value that we would have to find. So that's the thing, is if the y-intercept is equal to 16, then you know that 0 is for x, and 16 would be for y. And then the only thing that I would have left over would be, what if I put a 0 in for x? Well, I've got the 1 minus 2 minus 4. And when I multiply that all together, I get a positive 8a, divide by 8, and a equals 2. So I just bring the a right back up here, and that's how we got the answer. This is the long algebraic way to do it if you weren't given a multiple choice option to compare to. Okay, but we did the warm-up like this on Monday. Okay. All right, here it is, last one. No, just kidding, not last one. Describe the degree and leading coefficient of the graph. All right, nicely done. Let's just talk about this one quick. So what do we know? We know that one arrow starts high and the other one starts goes low, so it's definitely an odd degree. And the fact that I'm higher on the left and lower on the right means I'm decreasing overall from left to right, which means we have to have a negative as your leading coefficient. Oh boy, 10. All right, here it is. This is the last one. How many turning points are shown on the graph? All right, so turning points. What are turning points? Turning points are the total amount of maximums and minimums. So I have one local minimum and one local maximum, so I have a total of 2. Moment of truth. Third place, Mr. Straub. Curious who that was. Nicely done. Noah, nice job. And Timmy. All right. Well done. I'll just tell you this. If you feel comfortable with what we just did, and you've done the last 2 quizzes, you could probably take the test right now and do very well. I think that we have done enough review with warm-ups, and you guys have been doing well on quizzes and homework, so that's where we're at. I do want to just kind of quickly let you know what is on the test, just so you have an idea. So the Chapter 5 test, actually let me turn off this Kahoot. Okay. 90-minute time limit, which means when you open it up on Schoology, you have to take it there. Don't open it up and then do something else and forget about it, because that'll kind of take your time. So you only get one opportunity to take it. There are 11 questions. Most of them are multiple choice. There's a couple ones where you just type in like a fill in the blank, and then there's 1 or 2 where you have to write your answer in. If I remember right, there's something where you have to type in an equation. And let's say that you wanted to type this equation into Schoology. Well, we don't, it doesn't have the capabilities for us to do the 7th or the 4th power. So what I would have you do is if you're going to type that in, you're going to use that caret symbol, which is shift number 6, and there's a reminder on a question like that. So that would represent 3 to the 7th power. And then plus 3x to the 4th power like that, plus 3. And so that notation is the same as the raising it to the power, just so you know. What are the topics? Well, basically what we just covered. Right? Add, subtract, multiply, divide polynomials. We had 4 different methods of factoring. That was our warm-up today. Analyzing graphical features of polynomials. So if I give you a graph, can you identify the max, the min, x or y-intercept, the degree, odd or even, and then end behavior. So you might want to look back at that one because that was kind of the newer concept out of all of these. We might ask you to write an equation of a polynomial given x-intercepts and one other point, which is usually the y-intercept. And that was the one that I showed you the really long way, but you could have done it faster if it was multiple choice. And then, what if I give you a graph? Can you write the equation from the graph? Well, notice this problem right here is really the same thing as this problem right here. Because if I give you x-intercepts or I give you a graph, you should be able to read the graph to get the x-intercepts and read the graph to get another point, which is usually the y-intercept. So, we've got about, let's see, we get out of here at 9:15. Are there any questions that you guys had from the chapter review that you want to look at quick? If you on Zoom, if anybody's on Zoom and there were one of the ones that you wanted to look at, I do want to mention one thing, and I think this happened. When I put this slide up, I think I had number 41 as a question you had to do. That was my fault. You did not have to do number 41. We did not teach that, and I apologize. It's written correctly on our Schoology site, and then this was an old slide from a previous year, and I forgot to take that off. So forget about 41. I apologize for any frustration or confusion. But I'll tell you what, if you can do this review, the only thing that's not really on this review is given a graph and analyzing it. And I felt like we did that quite well with our calculator. So if there's no questions on that, this was our agenda for the week. I just wanted to just kind of share this. So Monday, Tuesday, we did calculator skills and kind of reviewed graphing. Today was the Kahoot. Your homework tonight is to work on any and all missing work. Get that in. I updated grades on Monday, I think, and I sent out an email, a missing email to all parents, so you may have gotten them. So in that case, if you haven't turned any of that stuff in, please do so before Friday. The test is currently available, that if you have a 90-minute window tonight and you want to do it, you can do it. All right? And then just make sure that you turn in this review homework. I think it was, I believe on Monday, Tuesday in Schoology, that's where I put the actual assignment. So there's a quick question on Zoom about talking really quickly about number 29. So let's do that one here quick. I might scroll down, just readjust. All right, so let's look at 29 here. Given the polynomial of f of x and a factor it completely. So this is just saying, here's the polynomial. Can you factor that all the way? Well, they're telling us that this is a factor already. So what I want to do is I could do synthetic division. So we got a 1, minus 5, negative 2, and a 24. And then if I find the 0 here, that's a minus 2. So I'll play the synthetic division game. And I'm going to do this pretty quickly. So now notice, when I do synthetic division, notice how my remainder is 0, which that's a sign that this definitely is a factor. When you divide something and the remainder is 0, then you know that that is definitely a factor. Well, what's left over then is this polynomial right here. So think about what we did. We took the original f of x, and we said, you know what, f of x can really be written as the factor x plus 2, and then we just divided that out of it, and what was left over was x squared minus 7x plus 12, and the directions say factor completely. So then I'm just going to look at what's left over and say, you know what, can I factor that further? And you could do the box with the circle in it, or this is one that you might be able to do in your head. You know, to get x squared, I'll have to have an x and an x here. To get a 12, what are the factors of 12 that add up to give me negative 7? Negative 3 and negative 4. Yeah. So that factors, and we already knew that x plus 2 was a factor. So I'll ease your mind a little bit. We talked about this briefly in one problem in the notes. This exact style of question won't be on the test. However, it's a perfect question that just has you guys build off of what you know. So when you divide and you get a remainder of 0, that means that whatever you divided by is a factor of the original function. So then you could take what's left over and factor that further. And now, notice we could find the zeros. We could graph this because we have the x-intercepts. So that's a perfect question to just say, here's how it all comes together. Okay. Any other questions? Perfect. Well, that's all I have. So make sure you work on your missing work tonight. Those of you who are on Zoom, if you want to come back at 12:15, you can use our Zoom link, and I'll be on here. You could ask more questions during our afternoon session. Have a great day. Adios.